let's talk about a little bit the standard definitions of fire protection systems. Sometimes we see that the basic and mostly preferred fire protection system in the industry is automatic sprinklers. These are a fire suppression and control device that operates automatically when it's heat activated. So we need some heat to activate a sprinkler, and they have an element upon heating up to some degree, it activates and water discharges over the specified area to control the fire. And this is called the automatic sprinkler. So you don't need any kind of extra detection device because it's already a detection device. It has a heat activated thermal element. And an automatic sprinkler system is with pipes and water under pressure and allows water to be discharged immediately when a sprinkler head operates. So we explained the automatic sprinkler, and when the automatic sprinkler activates and operates, there should be a complete system with pipes and water under pressure behind it to work as an automatic sprinkler system. This is a system definition. And when we talk about detection system, a system consisting of detectors, controls, control panels, automatic and manual actuating mechanisms, all wirings, piping and tubing, and all associated equipment that is used to actuate an extinguishing system. So a detection system is mainly in standard descriptions described as a system to actuate an extinguishing system by manually or automatically. An automatic fire detector is a device designed to detect the presence of a fire signature and to initiate action. This action could be an alarm or operating a fire protection system. And kind of system detectors are fire gas detectors, heat detectors, different types of radiant energy sensing fire detectors or smoke detectors are explained as automatic fire detectors. So we can use these devices to either get an alarm to inform the residents or users of a building that there is a fire. You will hear an alarm, or you will activate some systems that I will show you in the next slides. You can activate these systems automatically or by manually. An automatic fire detection system is a fire detection system that senses the presence of a fire, smoke, or heat and activates a sprinkler system or an automatic alarm system. So this device is completely automatic. It is preset with some adjustment, and when detector device senses the presence of fire, the system operates or it gives an alarm. So it's an automatic system. So we will talk about first widely used sprinkler systems in most of the buildings we have in our schools, in the shopping centers that we cannot visit these days, or in libraries, in different types of buildings. We have always seen the sprinkler systems. These are also fire detection and fire extinguishing devices incomplete. So it's an automatical device that senses the heat coming from the fire, and it operates and extinguishes or controls the fire. So how a sprinkler system works?
Guess who's not getting their shoe deposit back?
Definitely not like this. So we need to know how it works. So we have to be careful as well what we are doing with the sprinkler systems in order to avoid accidental discharges and water damages. So when we look at a fire sprinkler, it looks like a single part, but it's composed of many items. It has different parts to make it a complete actuating device. It has a water hole, it's called orifice, and it's defined by the water flow per the pressure behind the sprinkler, and you have a defined value of K factor depending on increasing with the fire hazard or the installation height. So you have different kind of sprinklers with different K factors, namely the different flow rates of water when you need to open the sprinkler during a fire. If the fire load is too much, the water discharge will be more. So that will be different as a K factor. So that is defined by the size of the orifice, as you see on the bottom of the slide. And there is some kind of sealing material, and the sealing is kept in place with a glass bulb or a fusible link device that activates on a defined temperature. So what is the defined temperature is, for example, for this unit with red color is 68 Celsius. So when it is 68 degrees Celsius, this sprinkler head is, the glass bulb on the sprinkler head is explodes, and the waterway is completely open automatically with the spring mechanism, and the water comes. So this is parts of the sprinkler head and how it works. So we will see a short video now, which is 2000 times slower than the second. So you will see 2000 frames per second. It activates very fast. So again, we will see how fast it's working. So the waterway is open and the water comes and the sprinkler discharges the water to the fire. So this system is starting to work with the heat activation of the sprinkler. And the system components of a sprinkler system is consisting of the alarm valves, the piping system, and the sprinklers on the different parts of the building. So you can see on the ceilings or on the wall sometimes the sprinkler heads. So they are connected between them with the piping, and in the riser that we call the main pipe, we have an alarm valve. Why we call it as an alarm valve? This is a water flow alarm device. So when the water flows through this device, it gives an alarm, mechanical or electrical alarm. So when inside the building a sprinkler operates, you can have a signal electrically or mechanically sounding an alarm to you that there is a fire in the building. So everyone can evacuate the building and the fire brigade comes. So this system is working as an alarm system as well. Without having any detectors, the sprinklers are detectors itself for the fire. So in that schematic, you will see a combined system. So there is a water tank, fire pumps, sectional valves, which are called alarm valves. And if you have a system with freezing temperatures, you have a dry system. So you cannot keep water inside the freezing rooms that is below 4 degrees Celsius. In cold rooms, cold storage areas, you have to have dry systems. And the wet systems are only inside the normally heated areas or normal rooms, not in this unheated or freezing temperatures. So you have here, before the room, all the pipe is empty and filled with pressurized air with a compressor. So this is a dry system. With the dry system, we are avoiding the frost inside the pipe, and the system operation is possible when the sprinkler operates, the air releases from the pipe and the water fills the piping and controls the fire. And there is a detection and control panel controlling all these systems and seeing all the signals from water flows, the alarms, and it's informing the fire brigade from this panel. Also, we have the pump control cabinets in coordination with the flow switch, pressure switch. It's operating automatically and restarted manually. So it's a general system overview. So we will see from now, after this section, we will see some different kind of systems and how they work in actual fire. So we have different sprinkler system types, as you see on the schematic. We have dry system, we have wet systems, and in general, we have, especially in the projects in Turkey, almost in all projects, we have a fire water tank supplying our fire protection system, and there is a fire pump room, and inside the building we have an alarm valve and sprinkler systems. So there is a complete system consisting of water supply, pump system, and the valve systems. And in the end, we have the sprinklers. But we only see normally in our daily life the sprinkler head above our head. So when we see the sprinklers from now, we will think about the complete system that should be clearly big investment for any kind of facility. So you remember this schematic. This is a standard wet system, and all the pipes are filled with water. And when the sprinkler operates, the sprinkler discharges the water immediately onto the fire. So we use here wet alarm valves, which is called wet system alarm valves. And these valves are typically a check valve that allows the water flow in single direction on the sprinkler direction. And the target of this using this valve is to get an alarm from the system, also to test the system before the fire happens. So we want the system to inform us when there is a fire happens or a sprinkler operates, that should mechanically or electrically gives an alarm to us. So let's see in an animation how this wet system valve works.
A fire has started in the building. As the fire grows and the heat reaches the rated temperature, the sprinkler will activate. Since this is a wet system, water is already in the pipes, allowing the immediate delivery of water to the fire. After the sprinkler activates and water flow is established, the clapper is fully lifted off of the seat and the alarm ports are exposed, allowing water to enter and fill the alarm line. If the system is equipped with a retard chamber, there will be a slight delay as the chamber fills before activating the water flow alarm. The retard chamber is a device that prevents false trips by containing up to a gallon of water flow prior to creating an alarm. Inadvertent water flow will only be able to fill a portion of the retard chamber's capacity. The alarm line is equipped with a 1/8 restricted orifice that allows the retard chamber to externally drain and reduces false alarms. During a fire, a consistent flow of water enters the alarm trim and fills the retard chamber faster than the restriction can drain, and the water flow continues through to the alarm devices. The water will then activate the water flow alarm, alerting the fire department and informing building occupants to evacuate. The water motor gong is installed as a failsafe to any electrical alarms. The sprinklers continue to control the fire until the fire department arrives.
So I will operate again the same animation because it's a little bit fast explanation. So
a fire has started in the building. As the fire grows and the heat reaches the rated temperature, the sprinkler will activate. Since this is a wet system, water is already in the pipes, allowing the immediate delivery of water to the fire. After the sprinkler activates and water flow is established, the clapper is fully lifted off of the seat and the alarm ports are exposed, allowing water to enter and fill the alarm line. If the system is equipped with a retard chamber, there will be a slight delay as the chamber fills before activating the water flow alarm. The retard chamber is a device that prevents false trips by containing up to a gallon of water flow prior to creating an alarm. Inadvertent water flow will only be able to fill a portion of the retard chamber's capacity. The alarm line is equipped with a 1/8 restricted orifice that allows the retard chamber to externally drain and reduces false alarms. During a fire, a consistent flow of water enters the alarm trim and fills the retard chamber faster than the restriction can drain, and the water flow continues through to the alarm devices. The water will then activate the water flow alarm, alerting the fire department and informing building occupants to evacuate. The water motor gong is installed as a failsafe to any electrical alarms. The sprinklers continue to control the fire until the fire department arrives.
okay, this is basically a wet alarm valve by the name. You can see it works as an alarm device. It gives an alarm. Here you have a water motor alarm. It's like a gong. It turns with the water velocity and it gives an alarm mechanically, and it's ringing like a bell. So it gives a mechanical alarm to the building, to the people in the building to escape, and also fire brigade to approach the right place for the fire. So also we have here an electrical alarm device. When water comes here, the electrical alarm is giving to the fire detection panel, and it gives that signal as an alarm, as a secondary electrical alarm. Another application is the dry systems, and we use dry alarm valves in these kind of applications, and it looks like more complicated. So again, I will show you an animation how it works and where it is used. These kind of systems are especially used in the unheated areas, and
A fire has started in the building,
subject to the freezing.
As the fire grows and the heat reaches the sprinkler's rated temperature, the temperature-sensitive device and the automatic sprinkler operates. The temperature-sensitive device could be a fragile ball or a fusible link. Once the temperature-sensitive device operates, either the pip cap or the seal will be displaced by air pressure. Air escapes through the activated sprinklers, causing the air pressure within the outlet chamber of the valve, the trim, and the pipes to drop. If the system is equipped with an accelerator, a sudden drop of air pressure will cause the accelerator to activate, directing air pressure from the system side or outlet side of the dry pipe valve to the intermediate chamber of the dry pipe valve. If the air supply is equipped with an air maintenance device, air will pass through the air maintenance device to the system. As pressure reduces in the outlet chamber, the differential in the valve is equalized to a point that the remaining air pressure in the system cannot hold the clapper closed. The clapper is pushed open by the incoming water supply and then securely latched out of the way. Water flows through the valve and trim piping. The water flow alarms are activated. Water flows through the system, taking the path of least resistance to the open sprinklers. Air pressure will remain trapped in the pipes that are not in the critical path to the open sprinklers. As time passes, water will displace the remaining air and the lines will fill with water. The sprinklers continue to control the fire until the fire department arrives.
So this system keeps the pressure of the water, sprinkler water, inside the pipe with air pressure. The air pressure inside the valve. Second. The air pressure inside the pipe is keeping the valve closed. So we don't have any water inside the pipes in the room. So when the fire started, the sprinkler head is activated. So the sprinkler activated. After the activating, the air inside the pipes is being escaped from the pipe. So the air inside the pipe, air pressure is reducing. When the pressure drops, the system, the valve opens. Inside the valve clapper, inside the valve body, opens and releases the water inside the pipe. As you see on the ceiling, the water passes all the pipes and goes to the open sprinkler, and just above the fire, it discharges the water. So normally before the activation of the system, we don't have any water inside the pipes. So this is called dry system and dry alarm valve. And it's again giving an alarm like mechanical alarm and electrical alarm that the system operated, and it gives information about the system operation. And we have another system called the deluge valves. The deluge valve systems are used in mainly spray systems that we have open kind of sprinklers or open nozzles. That means they don't have any temperature activation devices. All are open, and when you send the water from the main system or main valve, all the nozzles or openings release water at the same time. So not only the activated sprinkler, because we don't have here a heat activated sprinkler, all of them are open, or any kind of different device, nozzle, open devices. So the water comes out from all the open items, opening on the pipes. There we have an activation, electrical activation panel, and we have a detector system. So electronical detectors like smoke detectors, flame detectors, or other kinds of fire detectors are connected to the activation panel. Here you see the fire extinguishing panel. And the panel activates when you have a fire alarm. The panel activates these 24-volt solenoid that activates and releases the pressure inside the valve and opens it and sends the water to the pipes. And this system also has no water inside the pipes, but also no pressurized air inside the pipe. It's open completely. So it's different kind of a system that I will show you in a foam system example in coming slides. And we have another system called pre-action system. Pre-action valve systems are as coming from its name, is pre-action and pre-alarm systems. So when you have, for example, here we see double interlock pre-action system, and when you have this kind of system, the only way you will see water coming from the sprinklers is activation of the sprinkler and the detection both activated at the same time. So for example, somebody hit the sprinkler and we don't have any fire in the room. Somebody hit the sprinkler by accident and it's open. So we have a very important room, historical records or archives or very expensive devices inside the room. So if somebody accidentally hit a sprinkler, there should not be any water coming out of sprinkler by accident, because it will be more harmful than fire to the documents inside or to the devices that we protect. So it should be a pre-action system. When a sprinkler broke accidentally, the system gives you an alarm that yes, here there is a problem, a sprinkler open, but the detector doesn't give us a smoke alarm, so there is no fire. So in order to be a fire, there should be two actions needed. So this is called pre-action alarm valves. So it gives you an information that there is a problem at first, and if there is no, there is one of the systems not operated, like detectors or sprinklers, it will not release water inside the room. So this is a pre-action alarm valve system. So it is in general used in also cold storage rooms that requires dry systems. The pipes are filled in with pressurized air, and we don't have water inside the pipes. Just to protect the room, we are protecting the devices or material inside accidental water discharge. So this is kind of a double safety system when you consider about very special and expensive room materials. So these are our different types of sprinklers and spray systems and the alarm valve systems. So they are all in coordination with the alarm and detection systems, but these are the widely used fire protection systems in general in all the buildings that we are living in or we are studying or we are using. So these are the main and widely used protection systems in our life and their relation